we've got another one of these lessons. Let's go through the graphs. So I'm going to start with the completing the square question just because you're here. So we have y equals 2x squared minus 20x plus 58, right? So completing the square, as you are probably already aware, can only happen if the number in front of x squared is 1. So what we have to do first is we have to actually factorize out the 2 from these first things. Hey Evie, how are you? I'm just quickly going through a completing the square thing. Essentially the question was, what happens if there's a 2 in front of the x squared? How does it affect the turning points and things like that? I'm good, thank you. Very well. So I'm just going through that quickly just before we get into the other graph stuff. This does count as graph stuff in my opinion, but I'm just going to go through this real quick first. So the first thing you need to do is actually factorize out whatever number's in front of the x squared, and then you do completing the square on the stuff that's inside the brackets. Okay? So we have 2, then we have x, and you flip the sign of that, so minus 5 squared minus 5 squared, and then plus 58. Again, stop me the second that you're not sure, and tell me what line it is as well, because don't forget there's a delay on the stream, which is slightly annoying, but I can't really do much about it. Minus 25. Now we can actually expand the big staple brackets that I have. So we have 2x minus 5. This one. So from here to here, I'm actually doing the completing the square thing. So completing the square just says that x squared plus bx, you can write that as x minus b over 2 squared minus... So it actually comes from the actual completing the square formula. Is that like when you try to get back to the original number? Oh, okay, I know what you're talking about. If I remember that method. So essentially, yes, but where that comes from is the actual completing the square method, which is this bit here. So we have x minus b over 2, and then minus b over 2 again, squared. Does that make sense? I can give you an example if you'd like. But if that makes sense, then I'll move on. So wait, does that make sense? Yeah? Okay, perfect, cool. And then minus 50 plus 58. So then, of course, you just have 2x minus 5 squared plus 8. So then when you're looking at the turning points of this, so remember this is still y equals, all you do is you flip the sign of the thing here, and you have that. That is your turning point. So the 2 outside the brackets doesn't affect it. If you want to know why, let's have a look. For a turning point, we're trying to make this as small as humanly possible, right? So effectively, not equal to 0 actually, let's not do that. We want to make this function as small as possible. That happens when this bracket, sorry, this should have a squared, this bracket is equal to 0, right? So that happens when x equals 5, right? Now if that bracket equals 0, the whole thing goes to 0 anyway, including the 2. So we don't need to worry about it. So the 2 doesn't really affect anything. But what it does affect is this 8 on the end, because don't forget we did 2 times minus 25. So you still have to include it, but it doesn't affect the coordinates, if that makes sense. And Evie, you'll be happy to know that we're actually going through the graph stuff that you wanted to earlier. So I wrote down on a notepad everything you need to know. So I'm going to use that as a little bit of a reference just to make sure I cover everything. But I also have a ton of questions. Some of them are from before 2018 as well. So some of them are a bit different. To be honest, there aren't really any particularly difficult questions. Even when I went before, like, you know, when I said the old spec stuff, I even looked there really wasn't that much in terms of difficulty. But I've got a few different examples. Hopefully it'll give you some, you know, some amount of challenge or something. And Lila, are you okay with that? Can I get rid of it? Because I would like to start the other ones. Okay. And I'm going to go through literally, this is everything that's on your spec here. I'm going to go through each point. Yeah, I'm good, thanks. Perfect. So I'm going to go through each point just to make sure we cover the whole thing, because again, I believe some of you haven't been taught this before. So the first thing is plot straight line graphs. This is probably fairly easy, and you do kind of do it in science as well. But essentially, if they gave you an equation like y equals 2x plus 1, and they said from... they might say x equals 0 to x equals 4. When they say plot, that means you have to do a little plotting table, where this is going to be 0, 1, 2, and then 3, 4. And you're subbing each of these x values into here, right? So when x equals 0, y equals 2 times 0, which is 0, and then 1, and then so on. So then it'd be 2 plus 1 is 3, then it should be 5, then it'd be 7, then it'd be 9, right? Then you need to actually be able to draw that on a grid that they give you. So they will give you a grid, but just make sure you're able to have the spacings on the x-axis be even and the spacings on the y-axis be even, and that's it for plotting straight line graphs, right? When they say plotting, it just means you're subbing in numbers and actually putting it on, so it's not sketching. Okay. The next two things are kind of related, so you need to be able to look at the y equals mx plus c, right, and say if it's parallel or perpendicular or neither to another line, right? So for example, you may get given, let's say this is your expression. I was about to write the exact same thing again. They might say, okay, what about this equation here? Is it perpendicular, is it parallel, or is it neither, and why? So you would say that in this case it is perpendicular because it's the negative reciprocal of the gradient, right? So the gradient here is 2, the gradient here is minus a half. So the way you would phrase that though is you would say minus a half times 2 equals minus 1. That's the actual condition for perpendicularity, is that the gradients when times together give you minus 1. Now of course it's not always that simple. They might give you a formula that looks like this. They might say 2y plus 4x plus 3 equals 0 or something like that. You then need to put it into the y equals mx plus c form, right? Which hopefully you know that. Remember that the thing in front of y needs to just be 1. It can't be negative y, it can't be 2y, it can't be half y or anything like that. But that's... do either of you actually want me to go... Do any of you... Actually, how many people? Yeah, do any of you want me to kind of go through that, or is that all okay? I don't think it's particularly bad. Thanks, yeah. Again, some of these points will be a bit easy, but again, these are all of the points they can ask you about, okay? So if this is literally all of the graph section, all of it. The next point is you need to, you know what, I'm going to copy and paste what I wrote because I'm lazy. And I'm going to fill it in. I wrote it in shorthand. So what you need to do is calculate and estimate gradients and areas. Okay, so nonlinear graphs and quadratics are included in that. So what they mean by that is, let's take the basic example for fun. You need to be able to calculate the gradient of this line, right? Which should be easy. Find 2 points, calculate the change in y over the change in x, done. But you also might need to work out the area under the graph. So in this case that might be that area. So then all you do is look at what shape it is, right? It could be a trapezium, it could be a triangle, it could be a rectangle, whatever. Okay? That's not too bad. However, you may be asked to do it for non-linear graphs, so not straight line graphs. So it could be a graph that looks like, let's think of an example, this. They might say work out the area under the graph between these 2 points, so this area. And this is an estimate. So are you guys okay with how you can do that? So with a non-linear graph, or it could be like a quadratic, or I mean a quadratic is non-linear. Would you know how to do that? Just the first part. Don't worry about the rest of it for now. So, good. Okay, so with the gradient, you would draw a tangent, as Evie said. So with the gradient, they might say, what's the gradient? Actually, there's two ways they could write it. They might say, what's the gradient at x equals 4? Or they'll say, what's the instantaneous, and that's a big word, like rate of change at x equals 3 or something. When they say rate of change, that just means gradient. So that actually refers to this kind of thing here, the distance time graphs, the graphs in financial context, okay? Rate of change is just that, and all you do is draw a tangent. I believe there's an example question on that comes up later, but a tangent is just going to be, you find where x equals 4 is, which let's say is there, and you would draw a straight line that goes there. Okay? Evie, that is one way to do it, yeah. Okay, so that's what that would be for the gradient. You'd find the gradient of the tangent. Okay? So in terms of gradient, are we okay? Again, don't forget we have loads of exam questions, so we should cover all this anyway. I'm just talking about the method, alright? Okay. Now, okay, good. Perfect. Okay, now get rid of all this. Now, in terms of the finding the area, Evie kind of has the right idea. So basically, if you were to work out this kind of area here, so between the dotted line and the x-axis, there's a few things you can do. One thing is you can kind of estimate a shape. I know, so it doesn't always come up. It's really annoying. There are two methods. Normally on a graph, you have a grid, right, with squares. One option is to just count the number of squares between the x-axis and the y. So you might have to count all these different squares that are going up. That's one method, and that will work. Okay? The other method is you can make this into a shape. So for example, this shape here, it kind of looks like a trapezium, right? Like I have two different lengths, A and B, and then I also have like so it looks like a big trapezium looking thing, right? And then that would be the height. And then you could say that the area is equal to a half A plus B over H, right? That's another way to do it. So you can approximate it to a different shape, is what I'm trying to get at. And that's one way to do it. You can also make it two different shapes. So some people prefer to do good. Some people might also prefer to do like a rectangle down here plus a triangle, right? So then you have the area of this triangle and you'd add on a rectangle. Again, I believe we have some examples of this coming up. It doesn't come up very often. So when I was looking, I really struggled to find anything like this. A lot of the questions are relatively tame. So all you need to do is basically break it into two different shapes. It's always going to be an estimate, but try and break it into like a rectangle and a triangle, for example, or a trapezium, which is just a rectangle and a triangle anyway, or two triangles. So you can just do something like that. That's all you'll need to do. It's always an estimate, so you won't get the exact right answer, but that's okay. They normally give you a bit of wiggle room. Okay? Does that make sense on how you would like approach this in a real case? So in this case, you can break it into like a rectangle and then a triangle, or a trapezium, or something like that. Great. And Lila, how about you? Again, keep in mind, I do have actual questions coming up. It's not just going to be like this. Okay, good. It also says interpret results. Okay, so this is where I can actually teach you something a bit more substantial. So distance time graphs, velocity time graphs, and graphs in financial context. So this actually is somewhat common. So what I'll do is, let's say we have a distance time graph. Again, nice and straight. And you have a straight line graph. Okay? What they're going to say is, they might say something like, what is the speed? Histograms I didn't put in because it's not actually under the graph section of your spec, it's under the statistics section of your spec. But I'm more than happy to... I think we did histograms a while back. No, we didn't. Never mind. My bad. So we can do histograms then as well. But histograms aren't in this particular lesson because it's a different spec point. Like, topic. What is the speed of this object, right? So what they're basically expecting you to be able to do is relate the fact that the gradient of a distance time graph is equal to speed. Okay? So for example, in this case, would they ask that? I've never seen this, but something that they could ask you to do is, you know, I have this like exponential looking curve here. They could ask you, what's the instantaneous speed? Right? All that means is you're working out the gradient. That's all it means. Okay? So in this case here, what's the speed of this object? You would find the gradient of the line. Does that make sense? And you have to think about why the gradient of a distance time graph is speed, if you want as well. Yeah? I actually skipped a spec point. Whoops, I'll go back. Okay, perfect. And then do you also know about velocity time graphs? Or, actually wait, you guys call them speed time. No, velocity, cool. Man, these axes are perfect. So if you have like a velocity time graph, something like that, S equals d over t, well done. The gradient of this of a VT graph is just the acceleration, right? So if it's going upwards, it means you're accelerating positively. If it's going downwards, it means you're decelerating. And likewise, if it's a wibbly wobbly line, it means the acceleration is changing. Now, the area under a VT graph is just equal to distance. And the reason why, again, you can think about why the area gives you distance if you'd like. Is that all okay? And again, keep in mind, these graphs could look like this, like a curve. So if you're not sure of why, what it could look like, if what it means if it's curved, then yeah. No. There would be no need to square it for v squared. What you might be referring to is like an equation for velocity, but it's not needed for the graphs. Oh, thank you, Evie. I'm really glad that you're finding use of it. I was a bit concerned when I saw that some of the questions were really, they were quite basic and easy, and I was like, oh man, she's not gonna like this. But yeah, I'm really glad that you're finding it useful. And again, don't be afraid to say it's not useful as well, because I just like the facts. Fair enough, you know? It's good. Okay, so is that everything then? Hello, Alia. Okay. So, actually, one of the points that I'm going to come on to now, if this is all okay, is these are all the different types of graphs you need to... Oh, God, I've run out of space. All right, I'm going to go back up and then move to the right. The next thing is that these are the graphs you need to know, right? To recognize and sketch / transform. Okay? So I'm going to draw out all of the graphs and functions you need to be able to recognize and sketch and transform, okay? So again, this is all from your spec, so you can double check it if you'd like to, but I will show you that now. And yeah, we'll go through them one by one. So let's start with the obvious one, linear. So you need to be able to sketch recognize something that looks like this, y equals mx plus c. I don't need to draw that, do I? I think we're pretty okay with that, maybe. The next one is obviously a quadratic. So this is something that I have the formula y equals ax squared plus bx plus c. So again, that can either look like a smiley face, or it can look like a sad face. One thing to note as well is that these graphs, quadratics, are always symmetrical. Exponential is like compound interest. I'll actually show you what kind of form it takes in a second. But compound interest is actually an example of a exponential graph, yes. The next one is a basic cubic. So this one is going to look like this. Kx cubed. Whenever I use k from now on, it's just a constant. So it could be 1, it could be 2, 3, 4, 5, whatever, right? You may not have seen a cubic before, but I'm going to draw it out for you. That looks like this. It goes up, then it kind of goes flat, and then back up. It looks like half of a DNA, right? But again, remember, you also might need it the other way. So if this is negative, it'll actually go, and it'll actually make it a full DNA, like helix. But that's the cubic graph. So with the actual basic x cubed graph, there's no dip. However, if you have a cubic that has like more stuff in it, so maybe it has like bx squared plus, like it has some other stuff, then it will have dips and peaks. But for your exam, you actually only need to be able to recognize the normal one. You don't need the dip and the peak, according to your spec. But your teachers may have showed you it, which obviously is totally fine. Yeah. Cool. And again, don't forget these can be transformed, right? So again, you might have like a dip or something similar to that. The next one catches people off. It's called the reciprocal graph, which is 1 over x. Okay? And obviously this is where x cannot equal 0, because 1 divided by 0 gives you a math error. So the way you draw that is you have a curve here that never touches the x-axis or y-axis, and you have another one here that also never touches the x or y-axis. You can have a think about why the shape looks the way it does, and also why it can never touch the x or y-axis. There's a little fun thought experiment. Well, I say fun, as a thought experiment. Any questions about this? I should also remind you that for those of you that want to do A-level maths, these graphs all come back in force. Inverse, yes, Lila, well done. That is the one for inverse proportion, well done. Because with inverse proportion, you have, not 1 over x, so actually no, you do have 1 over x. And then you'd have like y equals k over x, right? So yeah, well done. Well recognised. Okay, all good so far. That's what I like to hear. The next graph we're going to go through is called the exponential graph. And this is just y is equal to some constant to the power of x. So if you have anything to the power of a variable, it's going to give you an exponential curve. So as Lila said earlier, this could be compound interest, right? It could be e to the x, if those of you that have done kind of A-level maths. So k is any number, but x is the thing that's changing, okay? And these all look exactly the same, which is really handy. It never touches the x-axis, good. And guess what else? It always crosses at 1. No matter what exponential graph you have, it's always going to cross at 1. And have a think about why. But yes, it never touches x-axis. In fact, I'll write that down. Never. And again, think about why it can't touch the x-axis. So if you want to get kind of better at doing graphs and everything, think about why these graphs have the shape they do. Okay? Think about why it can't touch an axis. Well done, Lila. Oh, perfect. Well done, Evie, as well. Anything to the power of 0 is 1, so it doesn't matter what this number is. It always crosses at 0, 1, the y-axis, 100% of the time, which is handy. But of course, remember, we can transform things, right? So think about what happens if you added 1 to it. Moves everything up, so it doesn't cross there. That's actually something we need to go through as well, is the transformations in a second. Lots of stuff to get through. Okay. Now you have your classic, assuming that's okay, now you have your classic sine, cos and tan. So you have your, there's no way to call it, just the sine graph, right? So y equals, can you use that factor and find y equals a k squared? Yes. You can sub in x equals 0 and then work out what that would be. So if there's a number in front of there, you can work out a from that, yeah. Nice work. Not bad. I'm assuming you mean that squared is actually 0, right? Or x, even. Sine graph. So there's a question a bit later on. Again, I'm really hoping I'm not mixing up my videos here. But it actually goes into the negative. So keep in mind, it looks something similar to this. Again, you need to know, ideally, from minus 360 to 360. But again, keep in mind, it literally follows a pattern. It's not too bad. Oh, you know what? The left-hand side is so much worse than the right. Oh. Pathetic. Anyway, so it starts off at 0, 0. Then every 90 degrees, it goes between like a few integers. So here at 90 degrees, it goes up to 1. Then another 90 degrees, so that's 180 degrees. It goes to 0 again. Then another 90 degrees, which is 270. It goes to negative 1. No wonders. So basically, we're going through all of the stuff related to graphs. So what I'm going through at the moment is your actual spec. So these are the different things you need to be able to do in your spec. And we're going through the different, at the moment, right now, we're going through what graphs you need to be able to recognize, sketch, and transform. So we start with linear, quadratic, cubic, reciprocal, exponential, and now we're going on to the sine graph. And then again, another 90 degrees. So the way I remember it is just every 90 degrees, we go between integers, right? So we go 0, 1, 0, minus 1, 0. And then going backwards, it would be the exact same thing, right? Minus 90 degrees brings us to minus 1. Are the questions on this just when you do the opposite to the sine graph, or are there different ones? So the most common ones I've seen for graphs like this are you need to transform it. So it might say, this is y equals sine x. Draw y equals sine x plus 1, right? And also, they might give you a point here that's coordinate A, and they'll say, what are the coordinates of point A? But obviously, they haven't given you the actual thing, right? They haven't given you the numbers that I've written on here, otherwise that'd be way too easy. So they'll just give you the shape, they won't give you any of the numbers, and they say, what are the coordinates of point A? They can also ask you to transform it. In fact, looking at the time, we might want to just go straight to doing the questions. So the next one is the cos x graph. It looks exactly the same as the sin x graph, except it's been shifted to the right. So instead of starting at 0, it starts at 1, and then it'll go like that. And then again on the left-hand side. Oh, something similar to that. So again, it's every 90 degrees, it's changing value. So again, I'm speeding up a bit because I don't want to waste your guys' time. But again, the cos x graph looks very similar to the sin x graph. It's just been shifted to the left or right by 90 degrees. Again, if you have any questions about this, let me know and we can go through it. But in the meantime, I'll draw up the tan graph, which I personally think is probably the hardest one to remember. It's going to be... I'm wondering if I should Google an image for you instead of drawing it. You know what? Nah. You're expected to draw it, so I'll draw it. So you have something that looks like this. And then it keeps going like that. Okay? And this is at 90 degrees. And then the next one would be at 270 degrees. Okay, so this here is 180 degrees, and so on. What do you mean by absolute value, Evie? So if by absolute value you mean like the no. No. That actually comes up in A level, it doesn't come up in GCSE. So again, this is actually directly from your spec. That kind of take the absolute values. It's not done. And the last thing you need to know is just the equation of the circle working out the tangent of a circle. So assuming that's all okay, we can get straight on to doing questions. And again, I've got the references for them. I've got a few different specs. But again, remember all three specs are the same. So remember, like OCR, EdXL, and AQA, they all follow the exact same spec. Okay? So it's good practice to kind of jump between the specs to test yourself as best as possible. So here it is, it's a multiple choice question. Here's a sketch of a graph. Circle the equation of the graph. K is a constant. So, which graph looks like that? Well, it's not going to be linear, so we can cross this one out, right? Because it's not a straight line. Is it k plus x? Well, again, this would be a straight line, right? So it's not that. It's not this, because that's also a straight line, so it must be this one. And again, if you remember the reciprocal graph that I drew up here, it does look very similar to just the top right part of this. Yeah, so it's option D, I guess you'd call it. Nice and easy. Again, they're not all like this. Good, I remembered the question correctly. So they give us the graph of y equals cos x, and they say draw on the grid below, draw the graph of y equals cos x minus 90. Don't ask me why there's this white thing here. Just when I opened it from the AQA website, it looked like this. So, we need to talk about how transformations work. There are 4 types. I'm going to write it out now. So normally, y equals f of x, right? So in this case, f of x is just cos x. Now, I'm going to write out a few different scenarios. If the number is outside of the bracket, right? So you have either this, or you have... or this, you affect y and do what it says, right? So this would be, you times the y coordinates, or y values, by a. So we do exactly what it says, right? And here we would do plus a to y values. And by values I mean coordinates, right? So if it's outside the bracket, right, then we affect y and we do exactly what it says. Now, if it's inside the bracket, this is where things get a bit weird. You actually do the opposite of what it says and you affect x. So here we have a times x, so we're going to be dividing x values by a instead of timesing. And likewise here, instead of adding a to all of the x values, we're going to be taking away a from x values. Okay. Now, of course, this is where the difficult part happens, right? It's deciding whether or not it's inside the bracket or outside. Well, if we look here, we can definitely see that it's inside the bracket. So what topic is the bit that has f of x in it called? It's called functions, yeah. exactly like Evie said. X minus 90, this is the same as doing f of x plus a. So what we're going to do is we're going to do the opposite and affect the x coordinates. So what we're doing is we're plussing 90 degrees to x. That's it. So essentially all of these points are going to move to the right by one step. So this is going to be, so this point here at 1 is going to move over here. This point here at 0 is going to move over here. That point is going to move over here. And 270 is moving here. It says to only go up to 360, so I'm not going to move this point, but can you see that this point here would just move over here? So at the moment what we have is we have that. So as you can see, it's just this part of the graph all moved to the right. This isn't fully correct, because don't forget, I need the values for 0 to 360. I don't have the value for 0. But if you remember, the cos graph just repeats. So this part of the graph will go down here, so this part is actually just going down to 0. So if you notice, this actually looks exactly like the sine graph. It's just a sine graph, right? So that would be it. Is that all okay? Does that make sense? Any questions? So Belinda, Alia, Lila, Evie? Any questions at all? Great. So again, inside the bracket, do the opposite and affect x. So the next one is draw the graph of 1 plus cos x. Well, this is obviously not inside the bracket, right? So it's going to be adding 1 to y, because this is actually just f of x plus a. Okay. So keep in mind, you might have something like y equals x squared, and then the transformed version is like x minus 2 squared. Again, it's inside the bracket, so it affects x and does the opposite. So that's kind of the key skill here. Remembering these rules is important, but you need to be able to tell if it's actually inside the bracket or outside the bracket. So what happens if I put x plus a instead of x in here? How would that actually affect the answer? So we can get rid of that for a second. So adding 1 to y, this is quite easy. All we're doing is moving everything up. So this coordinate here is 0, 1. Well, now it's going to be 0, 2. This coordinate here is 90, 0. So now it's 91. 180 minus 1 now becomes 180, 0. 270, 0 now becomes 271. 361 becomes 362. So again, it looks exactly the same. And again, bear in mind, they're not too strict on the shape, as long as it looks roughly like a cos graph. That's the only thing that's important. Is that all okay? You might be preing the next question and seeing something a bit funky even. We'll get onto that in a second. Great. Look at you guys, not bad. Again, remember, any questions, just let me know straight away, we can go through it. Okay, so, here's the graph of cos x. She tries to draw y equals cos minus x, and she gives this. And we have to give a reason why it's incorrect. This is a bit funky. Good. Y equals cos of minus x. So if we're timesing x by minus 1, since it's the opposite, we're dividing by minus 1, but can you see it's the same thing, right? So all we're doing is we're flipping the sign of the x values. That's what we should be doing, right? The other way to call this is a reflection in the y-axis. Now again, the reason why I've wrote flipping the sign is because we're just dividing x by minus 1. So all that does is it makes all of the x values negative, and any negative x values positive. Does that make sense? All okay? Yeah. Lila? And others? Okay. Perfect. Now, I'm actually going to quickly pull this over here. What if it was y equals minus cos x? Well, using the same logic, we would be timesing y values by minus 1. So all we'll be doing is flipping the sign of y values, and this is the same, which is the same as a reflection in the x-axis, sorry. There is a reason I've written this out as well. So these two things represent reflections, right? If the minus is outside the brackets, then it's a reflection in the x-axis. If it's inside the brackets, it's a reflection in the y-axis. There's a reason why I've said this, because if you look at Rita's graph, I'm going to draw out the cos graph again, but in a dotted line like they did previously. Right? That dotted line is y equals cos x. Can you see what she's done, I wonder? I'll give you a few seconds just to have a look. You don't have to answer, just have a think. What she's drawn is y equals minus cos x, because she's reflected in the x-axis instead. She's made the y values and flipped their sign. She should have flipped the x values. So what would that actually look like? Well, if we go back here, what she should have done is actually reflected it round to the other axis. So instead of plus 90 and 0, it should have been minus 90 and 0. So she should have drawn something that looks like this. Now, if you're really astute, you might notice that that actually wouldn't change the graph, because don't forget the cos graph is infinitely long. So it's already symmetrical. So if you reflect it, it doesn't do anything. Exactly, Lila. This cos of minus x would look the same, because the cos graph is symmetrical. It doesn't actually change. It'd be like if you, for example, if I draw the x squared graph, right, and I told you to reflect it in the y-axis, you would draw the same thing, because the negative x becomes positive y, and sorry, the negative x becomes positive x, and then the positive x becomes negative x. It's symmetrical. It does the same thing. It doesn't affect anything. So in actuality, she should have just drawn the exact same thing again. So my dotted line is what should be the correct answer. But really well done in figuring that out. Like, how could she do that? Because it wouldn't change. It would look exactly the same. Which is fine, by the way. So there's a special word for things like that. It just means it's invariant. So normally, if you just draw the exact same graph again, that's fine, but you can also write that it's just invariant, which means it doesn't vary, so it doesn't change. So give a reason why it's incorrect. Simply put, she reflected in the y-axis, no she didn't, the x-axis instead of the y-axis. That's the reason why it's incorrect. Or, by the way, the other answer to this is y equals cos x is invariant under this transformation. Yep, but that's it. So, by the way, just as a bit of exam technique, I like to sprinkle this in every now and then. If you ever need to kind of give a reason why someone's incorrect, whether it's a calculation, a drawing, or whatever, the best thing to do is to draw it or calculate it yourself and see why yours is different. That's it. So you've seen those questions where it's like, you know, Dylan wants to work out 10% of this, he does this, why is he wrong? Best thing to do is just work out 10% of that number, right? And just say, well, why is it different? So what we did here, where I drew what she should have got, that is your method, right? Oh, voice is getting tired now. But I'm glad that all makes sense. I mean, look how much scrawling we've got. Cool. I'm hoping it does Makes sense completely. Okay, yeah, I think I know what this question is. So let's actually zoom out ever so slightly. So again, AQA question, but again, remember, it doesn't matter what exam board you're doing, they're all the same. So the graph shows the height above. I also have Edexcel questions coming up in a second, just FYI. The graph shows the height above ground of a toy rocket for 10 seconds. So this is basically a distance time graph, right? Because height is just the distance. For how long is the rocket in the air? So the number of people that circled 10 seconds, it was a lot. It's only in the air when the height isn't 0. So it's in the air from 4 to 10 seconds, which is 10 minus 4, 6 seconds. Good. But a surprising number of people circled 10. Because what they did is they looked here. Tunnel vision. They had binoculars on when they were doing the paper, apparently. But yeah. Easy done. It's easy done. I'm not going to lie. I've made very stupid mistake. Yeah. It's very easy to do. It's just tunnel vision. But again, if you... it sounds really condescending. Really condescending. But if you think about the context, right? It's in the air when the height isn't 0. Right? But in an exam, tunnel vision happens a lot. I mean, you've seen me make stupid mistakes, and I'm not even in an exam. Reminds you of that nice question about the train tunnel, or how long it was or something, right? Yeah. But yeah, that was kind of it. However, using the graph, estimate the speed of the rocket after 6 seconds. So remember, speed from a distance time graph is just the gradient, the surface area. Oh, that does sound cool. I don't quite remember that one, but I've done a lot. So we need to find the gradient at 6 seconds here. So, okay, small confession. This might not work because OneNote sucks. Yeah, it's not going to work. Alright. I'm going to have to draw this freehand. But you're right, it's going to be a tangent. You should use a ruler. Actually, wait. Right. Wait, no, let's do it the other way. I'm going to try and make it as... should be a bit steeper. Actually, a bit less. Again, I know you guys know how to do this probably, but I want to try and get a roughly accurate answer. I'd say that's kind of reasonable. And then all you do is you draw a straight line going as long as you can. Get rid of that ruler. It's not perfect. Yeah, it's kind of hard to draw this on... Alright, wait, can I... That's going to get me a better answer, but you know how to draw a tangent. It's just that on a computer it's a bit painful. But yeah, you draw a tangent and all you need to do is work out the gradient of that tangent. So best thing to do is choose a point where it kind of crosses right in the middle of the box. So let's say this coordinate here. And I'm looking for a good one. This one here. Then you draw a big triangle. Change in Y over change in X, right? Fairly standard. So this ends up at... So what is each one worth? So there's 1, 2, 3, 4, 5 boxes. Also, to work out how much each one is worth, what you do is you take the difference in the numbers, so 14 minus 12, and then you divide it by how many little boxes there are, so 1, 2, 3, 4, 5. I know you can do this without a calculator. 2/5, so each box is worth 0.4. So this point here is 14.4. This one here is 2. So the difference okay. If it gives you a specific time and you don't exactly hit the time, do they mark it based on your tangent? So okay, the mark schemes for this I think are a bit annoying. you need to make sure that your tangent hits the t equals 6. Because basically what they do is they give you a range of values, right? They might say anything between 10 to 12. Interesting, Lila. That might work for the science experiment questions, but in the mark schemes, it basically will give you a range. It will say anything between 10 and 12 is accepted. Or something like that, right? Depending on what the answer is. I don't know what the answer is because I haven't done the question yet. But, yeah. At least that's how it's worked from when I've done it. So, basically, as long as you get an answer that's reasonable, it's fine, right? This value crosses at 3.2, because again, there's 5 squares here, so that's 3.2. And this is 9. So 9 minus 3.2 is 5.8. So my value for the speed would be change in y over change in x, so 12.4 over 5.8. So 12.4 divided by 5.8 gives me, yeah, I'm not using that, 2.14, and then what would our units be? You get the units from the graph, okay? Don't always assume it's meters per second or miles per hour. In this case, the y-axis is in meters, so I'm going to write meters. And then we divided by seconds, so meters per second. But again, don't assume, please. Sometimes they have like kilometers per second, kilometers per hour, all kinds of weird, funky business, okay? So just check. The first unit is the y-axis, then slash, then the x-axis, always. So y divided by x. So that's a really good question. Normally they just accept mph as miles per hour. And if you did kilometers per hour, it'd be km/h. Technically, this should be like miles per hour, like that. But they use mph because if you look at cars, next time your parents are driving you, or your older siblings or whatever, it will say mph on it. So that's why they normally just accept mph. But normally it should be miles/h. A good question. Honestly, if you wrote the units out, like wrote meters, if you wrote it out fully like that, they would accept it. So if you're ever in doubt, just write out the full word. That's completely fine. Don't worry about it. They're not that anal about it. The Edexcel circle question. Which one was that? Wait, did I have it on here? Okay. So the annoying thing is I now have access to the AQA questions from last year, but I don't have the circle one just yet. But as you may notice, my school hasn't started back yet. They're starting tomorrow. Tomorrow I'll try and get the Edexcel 2022 paper or 2021 paper. I'm assuming you're talking about the 2022 one, right? I'll get it, but I actually wasn't in work today because we haven't opened yet. So I can't have access to it till tomorrow. Is it definitely online? Is that 2021, Evie? I haven't been able to find it. Okay. Excel 2022. Oh, okay. Circle question hard. Can we do that maybe next week? Because we're going to go back to doing the hard questions. Because we definitely won't have time today, because we haven't got much more time. So this one was the turning points. We did this at the beginning of the lesson, so I'm going to skip it for now because we only have like 6 minutes left. So the other type, so they give you a graph, and it says use estimates to find the solutions of. Now, can someone get live stream of other subjects is it only mathematics? So I am trying to find time to do science and maybe English as well. But again, it depends on the demand. I don't know how many people would watch a science one versus like an English one or something like that. So I can do GCSE science for sure. Yeah, it depends. So this question came up. It wasn't as easy, so well done. Wait. Other way around, Evie. So where this equals 0, you're basically looking at the x-intercepts and reading them off. Evie has the right idea. So all you need to do is find that that's 4.4 and negative 0.4. So the reason why is, don't forget, you're looking for where this crosses the x-axis, right? Yes, it does. Roots are solutions. They're synonyms of each other. No. You're right in what you're saying. The roots and the and are solutions. 100%. I know. I don't know why they have different words for it, to be honest. But actually, I do. I believe it's because of the quadratic formula. Because you know how you square root in the quadratic formula? They call it the roots. But, yeah. I feel kind of bad now. But, yeah. Well, it's a small thing. It's a real small thing. It's actually only... This top part is worth 1 mark. The bottom part is worth 2. And you'll see why in a second. But, yeah. It will be those 2 values. Yeah, so in this case, the algebra would be x minus 4.4, x plus 0.4 equals 0. Because you flip the sign to go back into the brackets. But yeah. Your teacher had lots of rants about giving roots as not coordinates. Not as coordinates. I mean, if it says find the coordinates, then find the coordinates. But roots, technically speaking, are single numbers. They're not coordinates. Okay, so the actual main reason I picked this question is because of this bit. What about these solutions for minus 6 instead of minus 2? So, this top graph, I'm going to call y equals f of x. Which means this bottom graph is f of x and then minus 4. How do I get the minus 4? Because we've gone from minus 2 to minus 6, which means we've subtracted another 4. Transform, good. So all we need to do is... It's actually not as bad as you think. What we're going to do is look for the coordinates where it crosses... okay. Let me start again. I lost track of that thought. All we're going to do, if we were to transform this by subtracting 4, we would move the whole graph down by 4, right? Which means all of the points that are on 4 at the moment will now be on 0. They would move down to 0. And the other coordinate here would be over here. That would move down to 0. Does that make sense? The other way to do it is to actually draw the whole graph. So again, if I move the whole graph down by 4, it should make... Thank you. Thank you. Which means we have now the x values where that would happen. So that would be 5.2. 5.2. And the other one would be minus 1.2. Unfortunately, I've drawn really big black marks on it. Yeah, minus 1.2. Again, it's an estimate, so although it's like just... Like if you look here, it's actually not directly on 1.2, it's just before it. But again, it's an estimate, so it's fine. To 1 decimal place, that would be correct. And then lastly, find estimates for the value that satisfy the simultaneous equation. So We already get given this equation, graph. However, this one is minus x plus 6. So what you need to do is actually put two values in. So when x equals 0, y equals 6. Let's draw that on. This is going to be hard for me to draw, by the way. And then pick any other x value. 2, right? So then y would equal minus 2 plus 6. I thought so as well. Again, it doesn't matter what two values you pick, by the way. 2 and 4 be here. So then you know your straight line. Oh, God, I really hope this works. Okay. I probably went the wrong way around on that. Not bad. Again, with an actual ruler. Honestly, that's not bad. That's not bad. These solutions here. Not just subbing for